Hello, good evening all. Mahesh, Shweta,
Good,
Chinmay, Birudev, Ashok. Good
good evening,
evening,
sir.
Good evening,
Good
sir.
evening, sir.
Ganesh. Good evening, Jayant. Good evening.
Good evening, sir. How are you?
Good evening, Ganesh. I'm good, Ganesh. How are you?
Good, sir.
Good. What is the status of door panel project? The first one done with the
Sir,
bit.
half picture,
Hmm?
picture complete. Picture completed, half.
Okay, 50% completed. Perfect. Okay. Others, Ashok, I think you have completed. Yes. Subhajit,
Yes, sir.
Chinmay also completed. I think. Yes, Chinmay. Raja,
Yes, sir.
Chinmay, Ashok has completed the first project. Jayant, what is the status?
सर मेरा स्टेटस क्लोज बोलो में सर आगे मैं बहुत
अटक
हैक कर
गया
रहा
है।
है सर मेरा सिस्टम।
Okay.
सर
Subhajit?
मैंने नया सिस्टम मैंने ले रखा मंगाया है सर वो उसके लिए।
Okay. Good. Subhajit?
सर मेरा ये सरफेस में अटक गया तो आई थिंक मास्टर सेक्शन बनाने में कोई दिक्कत है। एक बार मास्टर सेक्शन आपको सेंड कर दूंगा, एक बार वेरीफाई कर लेना सर।
Okay, no issue. Okay, Shweta? Shweta? Okay, no issue. Okay, anyone wants to share your screen of file, working file, anything?
Hello, sir.
Yes, Ashok.
Yes.
सर
Yesterday, I have sir shared for one file. I have that
That surfacing? C
creation of C
surface?
surface.
Okay,
Yes.
सर
okay.
मेरा डाउट वहाँ पर था सर थोड़ा।
Where?
सर जो
Raja?
अभी सर जो लोकेटर का था ना, विंडो और लोकेटर के
Hmm.
टॉलरेंस का, वहाँ पर था मेरा डाउट थोड़ा।
Window. Oh, okay, here. In this one?
हाँ ये सर।
Okay, just a minute. Let me check the file first. Where is the file? Ashok?
Sir, data share in data share.
Okay, this one. This?
Yes, sir.
Okay. Rajesh, shall we finish this surface first?
ये सर यस।
Okay. Then we will come back to your point. Okay. Can you see my screen? Is it visible properly? Is there any network
Uh,
issue or lag?
yes, sir. Yes, sir. Okay, sir.
Okay, good. So let me check. This is my MTD. Yes. Uh, Ashok, is there any difference between the axis Y and this MTD? Is there any angle?
Um, uh, no, sir. I think no.
Okay, let me check. I think there is some angle this and
Yes, sir.
this.
Yes, sir. Some I okay.
Why there is the angle of 1.6? Is there any reason?
Because firstly I made MTD along y direction, but
Hmm.
along z direction, but it is not satisfy that a surface. That's why I tilt with some angle.
Okay, is it a A-pillar surface?
Uh, uh, B pillars, I think so.
No,
It's a
B-pillar.
title of that file. B pillar.
No, it is only pillar. I think this
Okay.
should
Okay.
be A-pillar. Okay.
Yes.
So how to check? Is there any absolute access system? Yes.
Yes, sir.
Okay. Now tell me, is it a which side pillar? Left side or right side? Isometric view. Tell me, is it a A pillar or B pillar? Click on Z. This axis is your absolute axis system, yes or no?
Yes, sir.
Here will be a shaft. This will be a front wheel. Tell me, this is a pillar, B pillar, or C pillar?
A pillar.
A pillar.
A pillar, simple. Let's say if we are checking from the top side, so this will be left side or right side? This will be left side or right side? Quickly.
Sir,
Right
left
side,
side.
sir.
Left side.
Left side. This will be left side. See, this is our front side. Okay, this is our front side of the car. Okay, so this will be left side. Yes or no? Clear?
Yes, sir.
This will be right side. So this is left side A pillar. Got it?
Yes.
Clear? Ganesh, others?
Yes, sir.
Now, the issue is, sir, how to create the C surface. Okay. See, if we think technically, tell me this part will rest on some part. On which part it will rest? Quickly.
Sir, in BIW?
BIW, no, Subhajit. Not on BIW. It will rest on.
Roof and bottom.
Okay. Subhajit, you are correct. It will not rest on BIW. It will fix on BIW, Subhajit.
Yes, sir, fix it
It
there.
will fix on BIW, but it will rest on which one? Which environment part? Chinmay,
Sir, in,
Raja,
sir,
others?
in roof and
Dashboard.
Perfect. Dashboard and roof.
yes.
Okay. Now tell me there will be some condition that you will have to maintain the gap between this sea surface and your dashboard. Yes or no? Yes or no? There will be dashboard. Let's say this will be your dashboard. Yes? Something like this. Yes or no? This will be your dashboard. So you will need this surface, green surface. Yes, you will need the yellow surface, this one. Yes, then the requirement will be maintain the gap between the A pillar and the A surface of your dashboard. The gap should be of 0.2 mm. Yes or no? This will be the input in presentation. Ashok.
Yes.
Sir, why required, sir, gap? Means we directly we mount on that dashboard.
Okay, so what is the requirement of the gap? Okay, good question. As Subhajit mentioned, sir, on BIW we will mount or we will locate our A pillar close volume. Okay, the orange one is your BIW. On BIW you will have two holes and like this. Okay, you have these holes on BIW. This hole and this hole we will use for the locator. This hole and this hole we will use for the screwing or let's say fixations. Okay, clear?
Yes, sir.
Or let's say we will have clips on this position and on cross position we will have locator. Okay, Ashok,
Yes, sir.
the locator should be aligned with the holes which are in BIW. Yes,
Yes, sir.
while assembling first we will insert the locator inside that hole, then automatically the fixation holes will be aligned 1, 2 and 3. Automatically it will align with the BIW if
Yes,
you
sir.
locate this locator properly. Okay, now tell me, whenever you will design the locator, how much clearance you will keep from all four side as per our design standard 0.1 mm.
Point
Yes,
one.
remember?
Yes, sir.
0.1 mm. Suppose if you want to if you're keeping this surface in zero contact with the green surface, okay, and by mistake, tell me the green dashboard is also going to mount on BIW.
Yes, sir.
So there will be some variation in holes, in position, in locator. There will be also clearance. Yes.
Yes, sir.
So by mistake, if suppose the green surface is moved by 0.2 mm upward after assembly, if the dashboard is moved by 0.2 mm upside. Now you have kept zero contact between the A pillar and the dashboard. Tell me, first you will assemble the dashboard, then you want to assemble the A pillar. Will it be okay for the assembly if there is zero contact between the A pillar surface, close volume and the dashboard?
No, sir. Means just stack.
Sorry, Ashok?
No, sir. Means due to some dashboards come out for the
Hmm.
due to this A pillars not properly assembled at
Yes.
that location.
Okay. Now, suppose if your dashboard is coming upside by means 0.2 mm, and now you have kept zero contact means the completely A pillar is resting on this one. But in my case, what I will do, I will take the offset of this A surface of the dashboard and I will offset it by 0. Safe side, I will take 0.4 mm offset. Then I will, with help of that surface, I will create the C surface of A pillar. Now tell me what will the gap between the A pillar and the dashboard?
0.2, sir.
No, how much gap I have kept in design? Abhay, others, Ganesh,
2.7, 2.7.
why 2.7?
2.5.
What is the offset value I have considered? What is the offset value I have considered for the C surface?
2.5.
0.4. I mentioned I will offset this dashboard surface by 0.4 mm. That surface I will use to create the C surface of A pillar.
Yes, sir.
So what is the gap between A pillar and the dashboard in design?
0.4, sir.
0.4. Subhajit, Ganesh, Shweta, clear, others 9.
Sir,
Yes, sir.
can you
Abhay,
repeat again? Yes, sir.
okay. Yes, Subhajit.
Sir, can you repeat again?
Okay. Repeat again. From where, Subhajit? From which point?
Sir, point 4 total
Okay. Okay.
C
See,
set of.
you're going to assemble the dashboard on the BIW, okay?
Yes, sir.
While designing the dashboard with respect to BIW, we will keep some clearance due to some
Yes, sir.
machining allowance, shrinkage allowance, and all, okay? So let's say the allowance is 0.2 mm. So after assembly of dashboard on BIW, it may happen that dashboard will come up by 0.2 mm. Yes.
Yes, sir.
Now what Ashok is saying, sir, I want to keep zero gap between A pillar and the dashboard. Means Ashok wants to rest the A pillar on the dashboard. And we are going to assemble the complete A pillar on the BIW on this two hole, the cross hole. Yes.
Yes, sir.
And there will be three pins on this hole. So tell me if the dashboard is moved up by after assembly on BIW, the dashboard is moved up by 0.2 mm. Tell me, can you assemble the A pillar on the BIW properly? You have zero contact between A pillar and the dashboard.
No, sir.
Why not? Why no?
Sir, after, sir, there will be any maximum point 2 you are telling, sir, right?
Sorry,
सर डिफरेंस कितना होना चाहिए दोनों का गैप
We are not keeping any gap. Okay, Ashok doesn't want to keep any gap. Zero gap.
मतलब क्लियर कितना होना चाहिए वो समझ में नहीं आया
Sorry.
सर क्लियरेंस कितना होना चाहिए दोनों में वो आप कुछ एज्यूम कर रहे हो
क्लियरेंस का बात ही नहीं हुआ है अभी तक.
नहीं
See.
सर मेरे
Okay, no issue. See. This is BIW. Okay, let's say this is BIW. Okay, we have two holes on BIW where we are going to mount the complete dashboard in this direction. Okay, BIW
यस
पे हम डैशबोर्ड असेंबल कर रहे हैं, लेकिन हम यहाँ पे कुछ क्लियरेंस छोड़ेंगे क्योंकि जब भी कुछ भी हम डिजाइन करते हैं तो परफेक्टली डिजाइन तो नहीं कर पाते. डिजाइन कर लेंगे परफेक्टली, लेकिन मैन्युफैक्चरिंग में वो परफेक्टली जैसे डिजाइन किया है वैसे तो मैन्युफैक्चर नहीं होने वाला है. हम
यस
थोड़ा बहुत टॉलरेंस क्लियरेंस मेंटेन करेंगे हर जगह. यस.
Yes,
यस
yes.
सो लेट्स से कि डैशबोर्ड बीआरडब्ल्यू पे असेंबल करते वक्त मैंने 0.2 का क्लियरेंस रख दिया है. हमने सब लोग हम काम कर रहे हैं साथ में, तो हमने 0.2 का क्लियरेंस रख दिया था, लेकिन अशोक ए पिलर पे काम कर रहा है. ओके, अशोक ए पिलर पे काम कर रहा है, लेकिन जब डैशबोर्ड एक्चुअल मैन्युफैक्चर होके जब हमारे पास आ रहा है और जब हम पूरा डैशबोर्ड बीआरडब्ल्यू पे असेंबल कर रहे हैं, तो असेंबल करने के बाद हो सकता है वो डैशबोर्ड ऊपर जा सकता है 0.2 से, अदरवाइज नीचे भी आ सकता है 0.2 से 0.2
यस
mm.
सर
यस, क्योंकि हमने क्लियरेंस रखा था, उतना टॉलरेंस पकड़ा था. तो अशोक का कहना है सर मुझे ए पिलर एंड जो डैशबोर्ड का ए सरफेस है उसमें 0 गैप रखना है. ओके,
यस
लेकिन हम ए पिलर किस पे माउंट कर रहे हैं?
सर डैशबोर्ड और रूप के साथ
नहीं, मेरा क्वेश्चन अच्छे से सुनिए. किस पे माउंट कर रहे हैं?
हाँ बीएडब्ल्यू पे
बीआरडब्ल्यू पे. ओके, वी आर माउंटिंग ऑन बीआरडब्ल्यू. फिक्स करने वाले बीआरडब्ल्यू पे. तो बीआरडब्ल्यू मतलब ये ऑरेंज वाला कंसर्ट कर लीजिए. और ये जो क्रॉस दिख रहे हैं आपको यहाँ पे, ये हो गए अपने 2 लोकेटर. ओके,
यस सर
ये हो गए हमारे 2 लोकेटर जो बीआरडब्ल्यू के अंदर जाएंगे सबसे पहले. बाद में ये बाकी के जो 3-4 होल्स रहेंगे वहां पे अब हम क्लिप टॉवर वगैरह कुछ तो भी डाल देंगे, क्लिप्स रहेंगे. बराबर. क्लिप्स असेंबल, क्लिप्स लॉक होने के पहले हमारा सबसे पहला काम रहता है लोकेटर लोकेट होना विंडोज में, तभी वो क्लिप्स टावर होल्स में अलाइन हो जाएंगे. बराबर.
यस सर
सो आप बताइए अभी डैशबोर्ड बीआरडब्ल्यू पे असेंबल करने के बाद हमें पता चल रहा है कि डैशबोर्ड 0.2 mm से ऊपर चले गया है.
सर मैं वही पूछना चाहता था पॉइंट टू आपने क्लियरेंस रखा है उससे ज्यादा हो गया तो क्या होगा कैसे पॉइंट टू एज्यूम कर रहे हैं वही पूछ रहा हूँ
अरे अज्यूम नहीं कर, अभी का अज्यूम कर रहे हैं. कैसे अज्यूम कर रहे वो पॉइंट नहीं है हमारा.
ओके
सिर्फ अज्यूम किया है, डिजाइन में डालना तो पड़ेगा क्लियरेंस.
यस सर
अभी जब आप लोकेटर, ये विंडो है और ये आप लोकेटर जब डिजाइन करते हो तो कितना क्लियरेंस रखते हो आप चारों साइड में?
सर पॉइंट वन
0.1 रखते हो. तो लेट्स इमेजिन ये एक विंडो है, यहाँ पे आप लोकेटर डाल रहे हो डैशबोर्ड असेंबल करने के लिए, तो वहां पे भी आप 0.1 का बोथ साइड क्लियरेंस रखे हो. बराबर.
ओके ओके सर गॉट इट
तो इनसाइड इंस्टेड ऑफ 0.1 मैंने 0.2 बोल दिया. ओके,
ओके ओके
तो ये हो सकता है डैशबोर्ड ऊपर आ सकता है 0.2 mm से, नहीं तो नीचे भी जा सकता है. लेकिन जब अशोक ने ये सरफेस का जब क्लोज वॉल्यूम किया है, तो वहां पे डिजाइन में वहां उन्होंने कुछ भी क्लियरेंस कंसिडर किया ही नहीं है. उन्होंने डायरेक्ट डैशबोर्ड पे रेस्ट ए सरफेस रख दिया है ए पिलर का, और क्लोज वॉल्यूम कर दिया है, 0 गैप रखा है ए पिलर एंड डैशबोर्ड के बीच में.
फिर सर प्रॉब्लम होगा
अगर डैशबोर्ड असेंबल करने के बाद पता चल रहा है कि 0.2 mm ऊपर चले गया है, तो आप बताइए ये जो लोकेटर व्हाइट वाले जो अपने थे यहाँ पे, यस, व्हाइट वाले जो लोकेटर थे यहाँ पे, ये मिस अलाइन हो जाएंगे होल के साथ, ये भी ऊपर
यस
चले जाएंगे बिकॉज ऑफ डैशबोर्ड. बिकॉज
Yes, sir.
अशोक ने वहां पे 0 mm क्लियरेंस रखा था, कुछ भी क्लियरेंस नहीं रखा है, कॉन्टैक्ट पोजीशन कॉन्टैक्ट कंडीशन रखा है।
Yes, sir.
लेकिन मैं क्या करूंगा, व्हाट आई विल डू, आई विल जस्ट ऑफसेट दिस ए सरफेस बाय 0.4 mm, then I will use that surface to create the C surface for the lower portion of A pillar.
Okay, sir. Got it now.
ओके अभी बताइए डैशबोर्ड ऊपर कितना आएगा, नीचे कितना जाएगा? 0.2 mm से, क्योंकि उतना ही हमने क्लियरेंस रखा था डिजाइन में, उसके वो रेंज के बाहर जाएगा ही नहीं। ओके और जब मैं लोकेटर माउंट कर रहा हूँ BIW पे ए पिलर का, वहां पे भी हमने 0.1 का क्लियरेंस रखा था सर, फ्रॉम ऑल साइड। तो a pillar, if I want to assemble a pillar on the BIW, the tolerance will be plus minus 0.1, मतलब वो कम से कम 1 mm ऊपर आएगा, नहीं तो 1 mm नीचे जाएगा। परफेक्ट।
Yes, sir.
लेकिन हमने बीच में गैप कितना छोड़ा था क्लोज वॉल्यूम करते वक्त?
Sir, 0.2.
0.4।
Oh, sorry, 0.4. Yes.
तो गलती से अगर ए पिलर नीचे भी आ जाता है 0.1 से, तो 0.4 में से 0.1 चले गया। गलती से डैशबोर्ड ऊपर आ जाता है 0.2 mm से, तो 0.4 में से
So,
0.1 चले गया और 0.2 भी चले गया, तो 0.1 तो गैप रहेगा।
हाँ सर।
लेकिन आप बताइए असेंबली में कुछ इशू हो रहा है? अभी असेंबल हो रहे हैं दोनों पार्ट?
हाँ सर।
अशोक क्लियर?
Yes, sir.
एवरीवन, चिन्मय, गणेश, श्वेता, सचिन, अभय,
Yes, sir.
अदर टेंस,
Yes, sir.
10 कैंडिडेट। ओके जयंत। अशोक got your answer?
Sir, I want to means on which side that C surface clear. That my question, and how to means, how to
No,
calculate.
but this you got your answer for the zero gap?
Yes, yes, sir. Yes, sir.
Okay.
Sir, shall we take the gap from the corner of the sea surface?
See,
In between the dashboard and the sea surface?
the portion whatever close to your dashboard, you will have to take the reference of the environment part. Okay.
Okay.
Now, the question is where should we clear this surface? Again, it will depend on your environment part. Okay, Ashok.
Yes, sir.
You will have to check the surface of dashboard. Okay. For now,
Yes, sir.
if you are getting the task just to create a closed volume, then tell me this face you are clearing in upside or downside?
Which one, sir?
This vertical faces.
This is downward side.
Downside.
Downside.
TD.
Okay, let's keep like this isometric view. Now we will not use downside. We will use this name X, Y, and Z. Okay. Let's hide this one. Okay. I don't want the small angle of 1.6 degree. I will clear this in Y direction. Okay. Now tell me these faces will be cleared in which direction?
Along Y direction.
Y direction. You are going to assemble this part in which direction? On BW?
Uh,
Ganesh?
Y direction.
Y direction.
Y. Y direction.
Okay. Now this is your, as you mentioned, sir, I am going to clear these faces in Y direction. Rest. Okay. That means we have finalized, sir, I want to use Y direction. So let's put one MTD. Where is your tooling geometrical set? You should have one geometrical set as tooling. Alt IG tooling. Let's draw a line from point.
Bottom surface.
We will check. Now, for that we will need one MTD, Ganesh. Then we will do draft analysis. I don't want any angle. 0. Where is the line? Say okay. Sorry, support. I don't want this one. I want point and direction. Point will be this one. Direction will be Y. Okay. Let's change the property. Right click geometry graphics property. Blue, thick, and with dash. Let's consider this as MTD. Now, Ganesh. So what is the status of the lower portion? Now let's perform draft analysis. Okay, Ganesh. Show, put it in material mode. Yes. Double click on the draft. Put the compass on this one. Click on compass. Remove this one again. Keep on this. Select the surface. What is the value? 0.48. Good. Tell me, is it okay or not okay? Let's show the edges. All edges. Okay. Tell me the MTD is okay or not okay? The MTD is okay or not okay?
Not okay.
Not okay. Why, Ganesh?
Bottoms red and
Yeah,
blue.
we have the red patch. Okay. Clear. This is not okay. But tell me, these faces are clearing. Yes. Okay.
Yes.
Now, this is your red patch. Can you see this is your red patch? Yes. If suppose
Yes,
this
sir.
is your red patch, so tell me this C surface should be red or green. What do you think? Which will be easy? It should be green or red. Same from.
Red.
See, this is red, this is red. Just imagine the parting line. Tell me this, where will the parting line? In on this corner. Where will the parting line? Quickly.
Upper surface.
A surface. Like this. Yes or no? Yes.
Yes,
Again,
sir.
let's think. Click on ISO view. You want to keep parting line over here. Okay. But tell me, is it a left side pillar or right side pillar? Which is the A surface? The inner surface is the A surface or the outer one?
Outer surface.
Outer one. Now, Raja, tell me, this parting line is okay or not okay? Everyone, tell me the parting line. What you are saying, sir? Here is the parting line. Okay, you said that, sir. This will be the parting line. Yes, everyone. Yes or no?
Yes, sir. Yes, sir.
Tell me, is it okay or
Yes,
not
sir.
okay? Think practically. Okay, think practically. Is it okay or not okay?
Not okay, sir.
Why?
Because this is visible for passenger.
Perfect. Excellent, Ashok. Sir,
Yes.
not okay. This will be visible. Tell me, you want to purchase BMW. Will you take the will you purchase the BMW if there are some sharp edges like this? If this
No,
is your parting line, can you apply fillet on this one? Or it should be sharp?
feel it.
There
Fillet
should be
apply.
fillet. No, if suppose this is parting line, we will not apply fillet. Okay. What is the rule?
Yes.
For fillet, what is the rule? Will we apply fillet on the green and red surface this edge? No. If this is red, then only we'll apply fillet on the common edge. Yes.
Yes, sir.
That means your all C surface should be red or green.
Sir, green.
Why green?
Sir, because of it will be clear in empty.
Then
We can apply fillet.
we can apply fillet. Perfect. If these surfaces are green, sir, we can apply fillet on the A surface edges. Yes or no, Ashok?
Yes, sir.
So all vertical faces should be, means C surface should be green. Then only you can apply the fillet, otherwise it will be difficult. Clear?
Yes,
Yes,
sir.
yes.
Now, so this is MTD. So how to decide where should be the MTD? This is, if we consider this as a MTD, so these patches are not clear. These are not okay with respect to MTD. No issue. The direction of tooling will depend on your A pillar, BIW. You will have to check the whole axis. Okay, you will have multiple hole on the BIW. You will have to check the axis of that holes and the angle. The axis of the hole will be your MTD. Clear? Yes or
Yes,
no?
sir.
Yes, sir.
So for now, most of the time your axis, the whole axis will be on y direction. Okay, most of the time your whole axis will be on y direction. Okay, on VAW. So, so for now, what should I do? You can just try to change the direction. Tell me on which plane you will rotate this line. On which plane?
ZY planes.
YZ.
ZY.
Yeah, YZ plane. Perfect. Okay. You will have to rotate it little bit. I think it is something 1.6. Yes, Ashok?
Yes, sir. Downward side. Yes.
Downside, yes. Then only this will be cleared. Okay, but if you rotate that axis by 1.6 degree, can you imagine your complete fixation will be in 1.6 degree? Yes or no? Locator, snap,
Yes, sir.
tower, each and everything will be on 1.6. That's why you will need the reference of BIW fixation holes. And most of the time that holes will be in y direction. So in that case, you will have to change this style. In that case, you will have to change these patches. Okay? You will have to
Uh,
inform your styling team, sir, this surface are not okay because our fixation are in y direction. So this is my MTD. So please recreate the A surface for this two patch. If they are modifying this 2-3 patch, this edge will change and this fillet will change little bit. Got it?
yes, sir.
Clear? You will have to check manually by how much value if you tilt this line, the MTD, these surfaces will be cleared. Right now, I don't know, is this my new line? Yes. Draft analysis.
Sir,
Yes.
screen is not visible, sir.
Sorry. Now,
Yes, sir.
Yes, visible.
okay. So you will have to tilt this line by some value so that these faces will be cleared. This should be green. Yes, Ganesh?
Yes, sir.
Yes. So you will have to find out that value. Okay. It is not mandatory that it should be 1.6. It can be 1 degree as well. But you will have to check on
Can
1
you do
degree.
that, sir?
Sorry.
Can you do that?
Sorry.
Till
Can
the line by
okay, till the
1.6.
line. Okay, let's do it. Where is the axis? Okay, we don't have, okay, we have the absolute axis over here. It is current. Yes, it is current. Let's take uh let's take a common point over here. Let's extract this one. Control 2. Hide this one. Extract. Okay. No, I think we have the access system. Where is the access system? I think we will have to activate this one, the mode. No access. Okay. So we have the access system. Okay. So tell me Ganesh, on which support you will rotate this line? What do you think?
ZY.
ZY,
ZY.
perfect. Yes. So let's take a line. Point, which option should we use? Ganesh?
Angle normal to curve.
Perfect. Angle normal to curve. Curve will be
Old tooling line.
to line, or let's say Y. Okay. Support will be
YZ.
YZ plane. Point will be
Original point.
origin. Okay. Now tell me, angle should be upside or downside? What should
Downside.
downside? Okay. So I don't want to mention the value like this 355 degree. So instead of 355, what I will put? I will put minus value. 360 minus 355 means 5 degree. Okay. So I will put minus 5. Say preview. Got it? Downside minus 5. Yes, Ganesh.
Yes, sir.
Say okay. Change the color. Make it yellow for now. Thick and dash. Now let's perform draft analysis. Double click. Compass will be on yellow line. Compass again move. Again keep on this one. Tell me, is it clear now? Yes.
Yes, sir.
Now,
Yes.
do we need 5 degree or shall we reduce the value? Let's check. Instead of minus 5, let's use minus 1. Enter. Right click, local update, draft analysis. Double click. Let me check is it okay or not. Put the compass on the yellow line. Click on the compass. Remove. Again keep on yellow line. See, got it? Blue surface, red surface. Tell me 1 degree is okay or not okay, Ganesh?
Not okay.
Let's increase the value. Double click on the line. Make it minus 2. Okay. Enter. Again, right click and say local update. No, it will not work. We'll have to do again this same process. Compass on the line. Compass, remove. Remove again, put it on it. Tell me, is it clear now on 2 degree? Minus 2 degree.
Yes, sir.
Okay. Let's try to change the value. Let's make it minus 1.5. Let's find out the minimum deviation. Double click on the draft analysis. Compass on the MTD. Compass, remove. Remove and again keep on it. See, on minus 1.5, tell me is it okay or not okay?
Not okay.
Not okay.
Not okay.
Why? The blue surface. Got it, Ganesh?
Yes, sir.
So as Ashok mentioned, let's try minus 1.6. Enter. Draft. Compass will be on the line. Again draft. Remove it. Again put it. Got it, Ganesh? Why 1.6? See?
Yes, sir.
Okay. But we will try to keep Y MTD. Okay. So first time we will try. See, suppose if I receive this style, what I will do? First, where is my tool? Huh. First, I will need a pillar. Okay. A pillar BIW with fixation holes. Okay. Second thing, what I will need? Style. A pillar style. Okay. A pillar style. Okay. Then my first priority will be Y axis will be my MTD. Okay, y axis will be my MTD. If suppose y axis, if the A style is not okay with respect to this one, I will request to change the A style. So why? Because the axis of these holes are okay and are parallel to our MTD, y axis, absolute y axis. Clear? If
Yes.
the styling team is will means if they are not agree, okay, we are not going to change the A style. I think they will change because this is the minor surface. Okay, there will be no huge effect on the A style of the A pillar. Yes or no? This is a minor patch. They will agree. Okay. If suppose if they are changing this patch, only this patch we want to change, then we will receive the A style new one. There is two option. A the styling team will change the A surface. Otherwise, they will tell you, they will ask you to change the style on your side only. What means you will do it in CATIA. Okay, got it? Otherwise, they will modify the style and they will share with you. Again, perform the draft analysis with respect to y-axis. If this is okay, then you can start for the close volume. But this we
Sir,
are discussing regarding the project.
hello.
Okay, you have to do this in project, not in design test. In design test, you will have to just take the yellow line and make the close volume. That's it. Yes, Mahesh.
Sir, my question is there is any possibility for the BIW holes,
Hmm.
the axis of the BIW holes may tilt from the y-axis from
Yeah, there
some
will be
1
some.
degree, 2
Yes,
degree?
yes. It may tilt, but maximum time it should be in y direction. Okay. See, x, y, z direction are very important for us. Okay. Tell me, will you prefer the angle of 1.6 degree or will you prefer the pure y axis direction?
Pure y-axis.
Yeah,
Yes.
pure x, y, z axis. Yes.
Yes, sir.
See, what will happen? If you keep the 1.6 degree angle, complete fixation will be tilted by 1.6 degree. The part assembly direction will be changed by 1.6 degree. Okay. And again, it will affect on the gap between your A pillar and the dashboard. Yes or no?
Yes.
Everything will affect. So we will try to maintain the XYZ axis.
No, sir. My question is, if
Hmm.
they have provided us their
Hmm.
BIW of them,
Huh.
so if that BIW hole, the axis of their BIW holes
Hmm.
is tilted from the
Yeah,
y-axis
yeah, yeah.
already,
Maybe. Yeah, yeah.
so should we have to follow that whole axis or y-axis?
No, no.
That
You
is
will
my
have
question.
to follow the whole axis. See,
Okay.
as I mentioned, tell me, can you change the axis of the BIW? Is it
No, sir.
possible? No.
No.
Can you request the styling team or can you change the fixation in your design by small angle 1.6?
Mm,
It is in your
for the
control.
C
No? You
surface.
can, yes,
Yeah.
no, for the C's as well as the fixation.
Yeah. Yes.
You
Yes.
can change it, but we can't change the BIW. Yes.
Yes. We can.
So in that case, you will have to change. But if your BIW is okay with the y-axis, and if your style small patch is not okay, you can request the styling team to change the surface. Okay. Otherwise,
Yeah.
you can change the surface on your side. No issue.
Yes.
Then you can start the close volume and the fixations.
Yes. Yes.
If they tell change the MTD,
Sorry, Ganesh?
not if they not tell the change the MTD not surface. Then
No, sorry, I'm not getting your question. क्या बोल रहे हो आप?
वो बोलेंगे सरफेस नहीं चेंज करेंगे आप MTD चेंज करो
No,
तो
this will not happen. Okay. इवन
Hello,
दो
sir.
अगर वो बोल रहे हैं नहीं स्टाइल चेंज हम नहीं करेंगे, आप बताइए, अगर ये 2-3 पैचेस अगर चेंज भी कर दिए तो कुछ हो रहा है क्या? अफेक्ट हो रहा है स्टाइल पे? कुछ खराब होने वाला स्टाइल? यस?
नहीं सर।
1, 2, 3, ये पैच अगर थोड़ा सा आउट कर दिए डाउन साइड, कुछ होने वाला है?
नहीं सर।
नो। ओके, सो अगर वो बोल रहे हैं नहीं, तो देन यू इन दैट केस you will have to follow the yellow line. Okay, but again it will impact in your assembly direction, your all fixation and the parts which are and the environment parts which are fixed around this part. Okay, it will affect. So ऐसे आपको आप उनको उनको बताना है आप. Okay.
Yes sir.
Hello, sir.
Yes, Ashok.
Sir, means sir, top and bottom side of top and bottom sides A surface
Hmm.
only clear in A surface. Is it is correct, sir?
Sorry.
Only two sides means only two sides A surface, a C
Hmm.
surface.
Hmm.
That top and bottom.
Hmm.
That we are going to clear from along
Okay.
A surface clear direction.
हाँ.
This is means longer long. This is long side C surface means
This
that
side.
should be I think clear in inward
Left
side.
side. Yes.
Ah yes sir, it is
See,
correct.
this surface, C surface will be cleared in the left side. But if you want to fill it on this one, you will have to clear it on this side. Okay.
Yes sir.
आप पहले इसका सी
Yes, sir.
सरफेस बनाइए, आपको ऑटोमेटिक इमेजिन हो जाएगा कि कैसे पार्टिंग लाइन रहेगा.
नहीं सर बनाया था वो, लेकिन वो वही क्लियर उसी मतलब ए सरफेस के डायरेक्शन क्लियर हो रहा है, लेकिन मैं एज्यूम कर रहा था कि वो
हम्म.
इनसाइड क्लियर करना है, तो
नहीं
मैं
नहीं, यू
उधर
गॉट
ट्राई कर
द
रहा था कि वो
हाँ,
कैसे करेंगे।
you got the reason because we will apply
यस
fillet on this side as well as the bottom side. No need of fillet on this side. Yes, ये इस पे fillet का कुछ काम नहीं है. Yes, और एनी हाउ ये फेस आप राइट साइड में क्लियर नहीं कर सकते हो. यस, लेफ्ट साइड में क्लियर करना
यस सर।
पड़ेगा. सो द अपर वन सी सरफेस एंड द लोअर वन सी सरफेस ट्राई कीजिए, ग्रीन बनाओ, फिलेट अप्लाई
यस
कीजिए,
सर।
बाद में ऑटोमेटिकली आपको आइडिया आ जाएगा पार्टिंग लाइन कैसे रहेंगी. ओके.
यस सर।
ओके, एनी अदर डाउट?
सर वो विंडो वाला सर थोड़ा था.
ओके, दिस वन.
हाँ ये सर.
यस राजा.
सर जैसे कि यहाँ पर दिया गया है जो 19.5, तो 0.1 ऊपर और 0.1 नीचे, तो 0.2 हमारा टोटल हो गया 0.2.
हाँ.
तो 19.5 माइनस 0.2 19.3, तो 19.3 हमारा
नहीं नहीं नहीं,
दिया गया
नो
है.
नो, जस्ट अ मिनट. नहीं, वो 0.1 अभी कंसिडर मत कीजिए. ओके,
ओके सर.
अभी कंसिडर मत कीजिए, ये एग्जांपल में मत कंसिडर कीजिए. ओके, हमने यहाँ पे ये डायमेंशन रखा था, ये सिर्फ मैंने एक्सप्लेन करने के लिए यहाँ पे लिखा था कि हम यहाँ पे 0.1 गैप रखते हैं. ओके, लेकिन
यस
जब हमने ये कैलकुलेशन किए तो उसमें ये कंसिडर मत कीजिए. ओके,
ओके सर. तो
फॉर
सर
नाउ जो व्हाइट है उसको स्किप करके अगर आप कैलकुलेशन करोगे.
हाँ
यस,
यस सर.
आपका क्वेश्चन क्या है?
सर जैसे कि जो डाया 3 मिला है, तो 0.3,
हम्म.
तो 0.3 मेरे को जो ऊपर एच पे और भी पे, मतलब हॉरिजॉन्टल और वर्टिकल में, ऐसा मतलब लेना है कि वो एक दोनों का वैल्यू एक ही आएगा, ऐसे ही लेना है क्या मेरे को? वही क्वेश्चन था मेरा.
हाँ, यस, तभी जाके वो सर्कल बनेगा.
हाँ ये सर.
ओके, और ऐसा मैंडेटरी नहीं है सर ऐसा ही लेना है क्या? आप बताइए, ये हो गया 4-वे लोकेटर. यस, दिस इज अ 4-वे लोकेटर.
ये सर.
नाउ लेट्स डिस्कस 2-वे लोकेटर. ओके, So two-way locator में this from this side you will keep 0.1 0.1 okay, but two-way locator में ये तो बहुत छोटा रहेगा ऐसे. Yes.
यस सर.
तो ये केस में हम तो ये कंसिडर करेंगे ही नहीं, बिकॉज यहाँ पे हम बहुत बड़ा क्लियरेंस रखेंगे 2 mm 3 mm.
यस सर.
Yes, this will be 2 or 3 mm. So we will ignore this one, ignore this gap. Just we will calculate over here only. Okay,
Yes, sir.
because this is critical. Okay,
सर
this is 4-way, that's why we try to keep it equal.
सर जैसे कि
सर
यहाँ पर
सर हॉरिजॉन्टल गैप कितना रहेगा सर यहाँ पे एक से
Two-way?
मतलब जो हाँ टू वे में
You can keep it 2 mm 3 mm, no issue.
from both side or
From both
that,
side. This will be
okay.
2 mm, this will be 2 mm.
Okay.
2 3 mm, okay, no issue. So but here we will keep 0.1 0.1 0.2 0.2 from both side depending on the requirement assembly.
सर जैसे कि 4OA में सर 19.5 हमारा वर्स्ट केस है, तो हम लोग रखेंगे कि 19 पॉइंट प्लस माइनस 0.1 रखेंगे, 19 प्लस माइनस 0.1 रखेंगे, या
Where
फिर
0.1
पॉइंट सॉरी सर
19
0.3 आई थिंक 0.3 या 0.2 रखेंगे, 19 पॉइंट प्लस माइनस 0.2.
कहाँ पे where
तो सर जैसे कि 19.5 है ना हमारा वो
19.5 is a maximum material condition. हमारा डायमेंशन ये है.
हाँ, तो वर्स्ट केस के लिए हम 19.5 लेते हैं ना सर.
हाँ
उसके हाँ, तो उसके बाद उसी के हिसाब से हम लोग वो रखेंगे जो
ये
लोकेटर
पार्ट
का
का
लेंथ, लोकेटर का लेंथ.
हाँ
तो उसका रखेंगे हम 19 प्लस माइनस 0.2 या फिर
हाँ
0.3 रखेंगे.
here see this one.
हाँ ये सर 0.2 या फिर 0.3.
हाँ
और जैसे कि यहाँ पर वर्स्ट केस है 24.6.
हाँ
24.6. तो सर यहाँ पर क्या मैं रख सकता हूँ 24 प्लस माइनस 0.3 ऐसे कुछ ले सकता हूँ ना.
you can take it, no
0.3 या
issue.
0.4.
Yes, 0.3 or 0.4 you can take it, but you will have to do this calculation.
हाँ सर, हाँ
Okay,
0.3
आप पहले मुझे वैल्यू बताइए कितना लेना है आपको वर्टिकल के लिए. ये यहाँ पे वर्स्ट कंडीशन है 24.6. आपको कितना लेना है वर्टिकल लोकेटर के लिए, बताइए वैल्यू.
24 प्लस माइनस 0.2 लेता हूँ मैं सर.
0.2 mm. ओके, हमने लिया था 24.2, आपने बताया है 24 प्लस माइनस 0.2. ओके,
यस सर.
इसका मैक्सिमम कितना हो गया
24.2.
24.2 mm. और लोअर वैल्यू कितना हो गया इसका
23.8.
ओके, अभी आप बताइए. ओके, ध्यान से. दिस इज द होल डायमेंशन. ओके, वर्टिकल, the whole dimension vertical is 25 point something plus minus 0.4. okay, sorry, okay, 25 plus minus 0.4. okay, the maximum material condition will be this one 24.6. yes or no?
Yes sir.
$24.6. okay, for the locator the maximum material condition will be this one
24.2.
okay.
Yes
तो
sir.
अभी ये और ये असेंबल हो रहा है क्या, चेक करना है आपको.
हाँ ये सर असेंबल हो जाएगा.
क्लियरेंस कितना मिलेगा, व्हाट विल द
0.4.
क्लियरेंस 0.4 means 0.4 means upside can be 0.2, downside can be 0.2 clearance. yes, total will be
Yes sir.
0.4 ना.
Yes, sir.
So this value is okay, no issue.
हाँ ये सर मेरा क्वेश्चन था ओके सर, बट सर वो सर्कल तो नहीं बन रहा है ना सर, क्योंकि इधर हॉरिजॉन्टल में कुछ
सर्कल नहीं बन रहा है, ओके, सर्कल नहीं बन रहा है,
हाँ ये सर
बट विच इज द मिनिमम वैल्यू? ओके, यहाँ पे आपको क्लियरेंस मिला 0.2, ओके, सो वर्टिकल let's say vertical you got value of 0.4, yes or no?
ये सर
Now tell me horizontal. होरिजेंटल में कितना गैप मिला था हमें? 19.5
0.3
एंड नहीं 19.5 माइनस 19.2
2
कितना?
0.3 सर.
Tell me. Now you have to decide, so what should be the position and what should be the diameter? Okay. So it should be 0.4 or 0.3. I will take it as 0.15 or 0.2. Got it? Safe side. Yes or no, Raja? Are you getting my point?
No sir.
Axis, if the axis is deviated inside this circle, we will able to assemble the part, yes or no?
Yes sir.
If I take phi 0.3, then it will be very critical. अगर गलती से भी 0.3 आ जाता है तो वो एकदम कांटेक्ट हो जाएगा वहां पे, हो
हाँ
सकता है
ये
कभी कभी असेंबल भी नहीं हो सकता है. तो सेफ साइड व्हाट आई विल डू, आई विल यूज die for the position tolerance. I will use die 0.15 or 0.2 mm. Got it? मतलब 0.3 में से 0.2 गया तो 0.05 ये साइड, 0.05 ये साइड, हम सेफ साइड खेल रहे हैं बराबर,
yes
दोनों
sir.
साइड सेफ साइड है. और ये इसमें तो कुछ इशू है ही नहीं. 0.4 मतलब 0.1 अप साइड, 0.1 डाउन साइड. दिस इज ऑल्सो सेफ.
Yes sir.
So
Hello, sir. Sir.
position tolerance will be die 0.2 mm. Yes,
Hello,
Mahesh.
sir. My question is, if there is any vertical gap for any distance it may take, and for the horizontal is it is different, so we will consider for some position tolerance for the circular portion, right, sir? If
Yes,
by considering the lower side that in
the
here
minimum value.
horizontal it is the 0.3, so for the lower dimension we that point of view we will consider, right, sir?
Yes, yes. See, we will try to avoid our value or the deviation. See, what is our requirement? We should, our design should fulfill the requirement. Yes, the part what we have received after assembly, the gap and flush should be maintained. It is not possible to maintain 100% what you have designed in your design software. Okay. So safe side, we will have to keep small gaps, small tolerance, small extra materials. Okay, clear?
Okay sir. Yes
So
sir.
here the worst condition is 0.3 mm. So sir, shall we take the diameter of 0.3 mm? No, it will be very close. If suppose if your locator is shifted by 0.3 on one side, and suppose it is not able to assemble on BRW, then what you will do? Will you reject the part? The tool whatever you had designed, let's say 50 lakh you have invested on that tool, gone, no use of 50 lakh tool. Yes,
यस सर।
पार्ट मैन्युफैक्चर होने के बाद वो असेंबल ही नहीं हो रहा है, तो 50 लाख टूल से जो पार्ट बना है इंजेक्शन मोल्डिंग से, क्या करोगे आप उसका? रिजेक्ट। पार्ट रिजेक्ट हो रहा है मतलब टूल भी कुछ टूल में इश्यू है। फिर टूल में इश्यू
यस
इसलिए बिकॉज आपने डिजाइन करते वक्त उनको टॉलरेंस नहीं बताया था बराबर। गॉट इट?
ओके। यस सर। सर ये तो सर हो गया इसमें सर। तो जब मैं जैसे कि मैं जो GD&T में मैं इसको दूंगा, तो मैं वहां पर 0.2 और साइड में लिखूंगा मैक्सिमम एम, सर डाया में सर्कल में
या
रहेगा ना।
see, suppose there is a datum. Okay, so what is datum and all, we will cover this topic. Okay, suppose this is your datum. Okay, the line. Suppose this is your datum A. How to represent datum A?
ट्रायंगल विथ लाइन।
Okay, so this will be your datum A, and this will be your datum B. Okay, now you will put some dimension in white color, or let's say orange. Oh no, green. So I will put a
I have one
dimension.
question.
I will put a dimension horizontal and vertical. Okay,
Hello, sir.
this will be in box. Just a minute. This will be in box. Okay, without any tolerance. This will be in box. And means, sir, from this datum, I want to maintain 150 mm. From this datum, I want to maintain 200 mm. The dimension will be in box. Okay. Okay. Tell me, is it possible to maintain perfect 150 and 200 from both datum practically?
No, sir.
नो सर।
No. But for this dimension, we will give this circle, and in box we will mention the, just a minute, this should be a little bit bigger. Here I will mention phi,
सर पोजीशन टॉलरेंस सर।
sorry, position. Okay, this will be plus phi. Okay, we will have to remove this one. We will have to remove this line. .2. Okay, and this will be the, this is the position tolerance, that's it. Okay, but
डेटा
if,
में ऐड नहीं होगा पोजीशन टॉलरेंस में?
sorry,
डेटा में ऐड होगा ना बॉक्स में?
yes,
कौन से
here will
डेटा?
be datum, yes, on this side from where you have taken the position tolerance with respect to A, with respect to B. Okay, so if you are considering from this point and this side, you will get one point, and the meaning of position tolerance means this point, we allow this point to deviate inside this circle. Got it?
यस सर।
Okay, now so where we will mention the M and L. Here, if suppose, if you are mentioning the whole size like this, and the maximum material condition, here you can mention 25 instead of 25 plus minus 0.4. What I will mention 25. Okay, on the top side I will mention minus 0 or on the minus 0.4 mm. Okay, and I will say maximum material condition. Here, got it? Yes or no? Means we will not accept the part which will be lower than this value.
Yes, sir.
For whole, this will be the maximum material condition. Same for the locator. The upper value will be the maximum material condition. We will just mention in circle M. In circle, we will mention M. Clear?
वो तो सर 0.2 के बाद रहेगा ना सर्कल एम.
Yes, yes. 0.2, yes. Just a minute. Sorry. Okay. Whenever you are working on project, you will maintain one presentation. Okay. Whatever we had done just now, whatever we had done the calculations, what will be the final gap if we consider the all tolerance? What will the final gap? What will the minimum size of the hole? What should be the maximum size of the locator, considering the tolerance plus minus? This thing you have to consider in design.
Only that, sir.
Ha. What should be the gap between this part and this part?
Okay.
You have to decide this one. How you will maintain the gap and flush? How should be the 3D? Where will be the parting line? Where will be the MTD? You will be responsible for this. Okay.
मतलब
And
mainly position tolerance we consider mainly position tolerance for
yes,
the.
position the gap and flush this thing. And the final calculation of GD&T, the all tolerance plus minus position each and everything. The final calculation we call it as tolerance stack up. Okay. For
We don't
this,
do that,
no,
right,
no.
sir?
On your level, you will not do it. Okay. If you have the experience of 5 year 6 year above, then this thing will be expected from your side. Okay, at least basic tolerance stack up. Prashant, what is your suggestion? Prashant Panchal,
Yes, sir.
what is your suggestion?
Regarding GD&T, sir.
Yes.
Uh, right now, GD&T, I consider during the learning sessions, we don't need a GD&T. Whenever we get a more experience, while we are working assembly and when we are studying at the assembly stage, during that time, we need a GD&T. Sir.
So that time we will do tolerance stack up and all things.
Yes, sir. In the assembly, we do tolerance stack up.
And for that, we will have some team lead experts.
Yes, yes, sir. Team lead or managers will check these all things.
Okay, clear, Mahesh?
मतलब हम कैड में भी टॉलरेंस स्टैकअप के कंसिडर करके मतलब जो फीचर्स ऐड करेंगे हम सर तो उसको कंसिडर करके करेंगे
Yes, yes, yes.
टॉलरेंस स्टैकअप.
See, in one shot, we will never finalize our design. Okay, even though you have design locator, windows, for the basic thing, we will maintain 0.1, we will maintain 0.05 mm clearance. Okay, but
Yeah.
after tolerance stack up, what is tolerance stack up? The final calculation. Will your part assemble on the BRW or the structure part? The gap what you have left in design. Okay, what you have kept in your design, is it okay or not okay? So after calculations we will get idea, okay, no, this 0.1 will not going to work, we'll have to keep 0.25. Okay,
Okay. Actually, why I have asked because मतलब जहाँ पे मैं अभी मतलब वर्किंग हूँ तो मॉडल सिर्फ वो बेसिक नॉमिनल साइज पे ही सारे मॉडल्स मतलब क्रिएट करे जाते हैं और फिर ड्राइंग के टाइम पे फिर वहाँ पे टॉलरेंस वगैरह ड्राइंग्स के अंदर ही सारे मतलब टॉलरेंस जो भी इनपुट देते हैं वो सिर्फ
Yes.
वहाँ पे ही रहते हैं मतलब कैड के अंदर कुछ भी उनका मतलब टॉलरेंस का कुछ भी सीन नहीं रहता है.
No, then that is a wrong practice.
Yeah.
Okay. See. Can you see my screen? Yes.
Yes.
See. Where is my tool? Yeah. Suppose you're working on this part. Okay. Now, this is your second part. Okay. In between, you want to apply a screw. Yes. Okay.
Yes.
Here you have the screw boss. Like this. Okay. Now tell me you have to maintain this flush. This surface with this one. Yes.
Yes.
Tell me, will you keep contact between the yellow part and green part on this point?
That point I don't keep that for this
You will
boss surface I will keep.
you will keep resting on the boss. Yes.
Boss. Yes.
You will have to keep some gap over here 0.2, 0.5 mm.
Yes,
Yes.
sir.
1 mm, 2 mm. You will keep the gap. Then
Yes.
only it will be possible to raise the green part on the boss. Otherwise, your part will stuck on this wall.
Yes, sir.
So such type of thing you will have to consider.
In the CAD for the plastic.
In the CAD, yes.
Okay.
And for this flush, it is not possible to maintain 100% flush. Okay. Here we will have the tolerance. Let's say 0.3 mm. Means if I draw a neutral line like this is the neutral line. And if your green part is moving upside by 0.15, then it's okay. If your yellow part is going downside by 0.15, then it's okay, no issue. If your yellow part is going downside by 0.2 mm, then it is rejected. Okay. With respect to green part. So with respect to green and yellow, the maximum gap should be 0.3. Yes. Otherwise, we will reject it.
Okay.
So
it is standard, sir, 0.3 or 0.2?
No. I'm just giving the example.
Okay.
I think we should stop. It's 10:25. Okay. Raja clear? Ashok clear?
Yes, sir.
Yes, sir.
Others? Jayant, Shweta, Sachin, Akshay. Akshay, is this your first session?
Yes, sir.
Ganesh clear, Mahesh, Prashant, Panchal,
Yes, sir.
Chinmay. Subhajit Raja. Okay. Biridev clear, Jayant?
Yes, sir.
Perfect.
Yes, sir.
Hello, sir.
Yes, Ashok.
Sir, can you share, sir, any automotive sample?
Yes, sir.
Yes. Okay then. See you in next session. Thank you. Bye. Good night.
Good night, sir.
Good night, sir.
Good night, sir.
Good night all.